Hello friends, today we are going to talk about the one of the problem on the angular momentum, particularly the raising and the lowering operators, which we are going to operate on the some general function FLM. Okay, the some general test function FLM. Okay, L stands for the its eigenvalue corresponding to the angular momentum. L, and M stands for the its Z component of the angular that is we generally call it as a azimuthal angular momentum, but we will see in the later cases how it can be. Okay, so when these raising and lowering operators are going to operate on this test function, we'll get some eigenvalue, and then its eigen value corresponding to the M is going to get changed by the unity one. Okay, so its value of the M will change by the 1 unit is the important thing here. Okay, where ALM is some constant, and what is the question here? What is the ALM here if the eigenfunctions are to be normalized one? When we are going to normalize this function, what are the corresponding values of the ALM which we are going to see here? So what is the solution? As we know that the raising and lowering operator is defined as L plus or minus is equal to Lx plus or minus ILy. Okay, so consider the general operator mechanism on the test function g, that is bra f L plus or minus g on the kit g it is getting operated. Okay, so we just define the function L plus or minus operator, that is Lx plus minus ILy. Okay, and then just rewrite the function in terms of this independently one, and what we can have instead of the operating this function on the what we can say on the next kit vector, we can operate it on the bra vector as well. Okay, so what we can get it the bra vector, we have to make the complex conjugate of it so that it will be getting operated on the first operator, the bra operator. So the L minus plus operating on the bra f, and then the kit g as it is remain there. So here what we understood from here, that is a L plus or minus dagger will give us the L minus and the plus 1. Okay, so now let us consider the product of the this raising and the lowering operator, the lowering and the raising operator. So first I will just consider the lowering and the raising operator for and then we'll talk about the combined together as a result. So using the definition, so L minus L plus, so how we have to take the product over here is nothing but the L minus is nothing but the Lx minus ILy, and it has to be multiplied with the L plus Lx plus ILy, and this will result us into the its value as a L square minus Lz square minus H cross Lz. Okay, it is already we have seen in the theory part of it. So just try to operate this L minus and L plus operator on the FLM, and just replace the value of it, that is nothing but the FLM bra vector, and then it is going to get operated or sandwiched between this FLM bra and the kit vectors. So L square minus Lz square minus H cross Lz. So we are just trying to deal with here with its upper value, or L minus and L plus product only. So when as we know that when L square operates on the FLM, it gives us the value, that is nothing but the L into L plus 1 H cross square FLM. So and when Lz operates, Z component of the angular momentum operates on it, it gives us the M H cross FLM. So it's azimuthal component, it is its value is given. Therefore, so what we can have, just try to substitute this value in the our given vectors in the eigenfunctions, eigenvectors. So what we can have when this operator operates L square operates on the FLM will give us the L into L plus 1 H cross square value. LZ square means LZ operates twice on the FLM will give us the value of the M H cross 2 times, so it becomes M square H cross square minus M H cross square. This remains there. So what we can say, all these values are the constants, so it will come out of these factors. So what we can have, they are taken out of it, and this remains the out of the that eigenvalues. So this is what we can say normalized eigen function. So what we can have, this value is 1 so what we can have here is nothing but the its value is given to be this one. But as we have defined earlier, that the from the given definition of this, L plus or minus is FL operating on the FLM, so it gives us the ALM F L plus or minus M plus 1. So just if it is consider the left hand side of our function, then the FLM L minus L plus and then FLM operating on the bra and the kit factors. Okay, so it is sandwiched the L minus and L plus product, and what we will get it is nothing but the, when this L minus operator on the bra vector, then that becomes a L plus, and the L plus this operator will operate on this function, but this will operate on this function. But as we know that the, if it is operating on the its bra vector, then we have to take its complex conjugate, but the L plus complex conjugate becomes the L minus, and L minus complex conjugate becomes the L plus. So what we will get it, the corresponding eigenvalue becomes the ALM star for this, and the ALM for this. So ALM star, so this is normalized one, this is a unity one. So what we will get it, mod ALM square. So if we just compare these two equations, then we get the value of the mod ALM square is nothing but the L into L plus 1 minus M into M plus 1 H cross square. So from this we can conclude that ALM is equal to positive root we have considered here, root of the L into L plus 1 minus M into M plus 1 into outside bracket H cross square. So also in general, for the, if we consider the both the operators simultaneously, then the bra FLM is into the F L minus plus or L plus minus FLM, it is getting operated is equal to what we can have, this will going to get operated over here, so that becomes L plus minus FLM and L plus minus FLM again, and this gives us the value as L into L plus 1 minus M into M plus 1 H cross square. Now here I am just going to get comment over here that when here is the bottom ladder, and this is the top ladder, and then the what we can top rung of the ladder, and this is bottom rung. When we try to operate the L minus operator on this bottom rung, then we will get the 0. Okay, this will give us the 0. And similarly, if we just operate the L plus operator on the top rung, then we will also get the 0, because this there is no rung above the top rung, and there is no rung below the bottom. So this gives us the limit, what we can say, extremities of this eigenvalues. Okay, and in general what we can have, there will be the some f function where we can have the some eigenvalue corresponding to the it is a FLM. Okay, ALM. Thank you.